You don't just write an answer, okay? You have to do some working out and you have to provide reasons. That's why today I'm going to give you the acceptable reasons for geometry. Okay, I've got some copies which I made yesterday. So I'm going to give you a copy of the acceptable reasons. Right. So yesterday I did the first one. Okay, here I did 1.1.1. So today I'm going to talk about 1.2, then 1.1.2, then 1.2, and the homework as well. Right. So for this question 1.1.2, you're supposed to find the length of AB. So AB is that whole length there. That's AB. Okay? Now, based on yesterday's answers, okay, just allow me to add them here. So I've got EC as 12 centimeters. So EC is 12 centimeters. Because I'm going to need that information to do the question. Okay, so if I want to calculate AB, it means that the triangle that I have to use is going to be the bigger triangle, which is triangle ABC. Okay, in triangle ABC, there is a line which divides the two sides of the triangle in proportion, and that line is what? DE. Okay, remember what I said yesterday? Before you use the proportion theorem, you identify a triangle which has got a line inside it which is parallel to one of its three sides. Okay, so I'm going to start by right here in triangle ABC, because that's the triangle I'm going to apply the proportion theorem in. If you are in my class, as you are, this is how I expect you to approach the question. Don't just start writing things, okay? Let the person who mark your work smile whilst they are marking your work. Right, so AB is part of triangle ABC, okay? Now, yesterday I used the original proportion theorem to calculate the length of EC. Now, to determine the length of AB, I'm going to use one of the four corollaries. Okay, remember I told you about the corollaries yesterday. So if I want to calculate AB, in this case, I know AE and I know EC, which means AC is going to be 8 plus 12, which is what? 20. Right? And I also know the length of AF is 4, of FD is what? 6. So I'm going to write my proportion theorem as AB divided by, so it will be AB divided by AD. I'm using one of the corollaries. Okay? So AB divided by AD. It's not the only way. I could also write it as AD over AB. Okay? Then this is equal to, since I started with AB as my numerator, obviously for the other side I have to start with what? AC. So that will be AC over AE. And then write your reason, line parallel to one side of triangle. Okay. Then I have to substitute now. So when I substitute my AD, that's the one I want to calculate. My AD will be 6 plus 4, which is 10. And my AC is going to be 8 plus 12, which is 20. And AE is equal to 8. Once you get to this point, you are in grade 8 or grade 9. Okay? To solve for AB, that will be AB is equal to 20 times 10 over 8. And that will give you 200 over 8. Okay, this is AB. But when I was moving around, I saw some of you with this answer, but the 8 was the numerator. There is no way that AB can be less than, say, AF or FD. So when you're answering the questions, also use common sense, right? What is 200 divided by 8? 25. So that will give you what? 25 centimeters. Okay. Please be aware that the proportion theorem can be written using the original ratios of the proof plus any of the 4 corollaries, depending on the question. All right. Any question? Okay, if you don't have a question, then let's move on to the next one. Now, the next question is on area. Now, before I talk about this question, I just want to do a quick recap of ratio. Okay? Please be aware that for ratios, if I give you x over y, this is also equivalent to x is to y, and it's also equal to x to y. It's the same. Okay? So here I'm gonna write it in normal ratio form. My answer must be in normal ratio form. But when I do the calculation, I can do the calculation using fractions. There is a relationship between fractions and ratio. Right, so if I want to calculate the length of AFE, in this case you might need a highlighter. Okay, fortunately I've got mine here. Okay, so I'm going to use these 2 colors. So the triangle that I have is AFE. So AFE is that triangle. That's AFE. Then I also have ABC, which is the bigger one. Okay, so that's my ABC. So if I were to ask you, what is common between those 2 triangles? Huh? They share a common what? Angle. They share a common vertex, but this case now, it's a unique case. Remember we said if 2 triangles share a common vertex, means their height is the same, but here it's not true because triangle AFE is too small for it to share a common height with triangle ABC. Okay, so sometimes triangles may share a common vertex, but if one of the 2 triangles is too small, they cannot share a common height. Okay, so if you want to determine the ratio of their areas here, we go back to grade 11, the area rule. So we have to use the area rule for a case like this. Okay, so if you use the area rule, I'm going to show you 2 methods, by the way, of doing the question, right? The area rule. So if you use the area rule, I'm going to go back to my lengths now. I know this is 12. Obviously, that's 8. I've calculated AB, and I got it as 25. So AB is 25. Okay. So if I want to find the area, the ratio of the areas, so I'll say area of triangle AFE is to the area of triangle ABC. Right? This one here is going to be half. Now in this case, it's going to be AF times AE, sine of angle A. And that one there is going to be half AB times AC. Good morning, this is a message for educators. Sine for please, will you be so kind as accept the RCL exit. Okay, so the next thing is to substitute now. So if I substitute, that will be half times AF, which is 4, and AE, that's 8, sine of A. And then here I'm going to have half, then times 25, times AC, which is 20, times sine A. Okay, now I'm sure you can remember that here we have got ratios. So if you've got a ratio, generally you divide by the highest common factor. Okay? So our highest common factor here has to come from the smallest of the 2 triangles. Alright? I hope you understand what I mean. If it's like this, if I give you a ratio like 14 is to 28, if you want to simplify this ratio here, you divide by each of these values by the highest common factor of 14 and what? 28. And it will be what? 14. So you end up having 14 there, 14, and you end up having 1 is to what? Is to 2. Okay. So here, this halfway, when I do the division, the two halves will cancel out. The sine A and the sine A is going to cancel out. So I'll be left with 4 times 8, which is 32. And here 25 by that will give me 500. Then the highest common factor of 532, what should be 8. So we divide this by 8. So you end up having 4 is 2. That will be 4 is 2.
I don't think the highest factor is.
No, it can't be 8.
It is 4.
No, it's not 8. It has to be 4. And so that will be 8 is 2, 125. Okay? So the ratio of the areas of those two triangles is going to be 8 is to 125. Okay? This is the answer, by the way. This is the answer. Because the answer is the ratio. Okay? The answer is a ratio. If you've got a question, please feel free to ask, and do yourself a favor. I expect everybody to be paying attention. Okay? You need to pay attention because some of you didn't do the work. Yes? Okay, for this case here, the main problem is that we don't have a highest common factor of 32 and 500, which will make us have a 1 here. Generally, when you are writing ratios, you are supposed to have integers. Okay? Because of the fact that your ratios must have integers, no decimals, you have to find the highest common factor. So, like in this case, the highest common factor is a 4, 32 and 500. So there is no way that you can end up having a 1 here. For this illustration which I gave you, you could have 1 is to 2 because 14 is also a common factor of what? 28. Are you following? Please do yourself a favor. I'm going to try and make this topic very easy for you, but you have to pay attention. Okay? So make sure you understood what I did here. So this is one typical example where you encounter the area of two triangles that share a common vertex, but they don't share a common height. If you see a case like that, straight away use the what? The area rule from grade 11.
So
yes.
What I did was I just put it as in its divided form. So
it's fine. Yeah, it will come to what I said here. Remember, x over y is the same as x is to y.
But so because it says the area, it must be that is to that. Do I have to at the end put it in that form?
Yeah. For this question, I would suggest you give your answer in the ratio form. But if you leave it out as 8 divided by 125, it's still acceptable. Because it's the same based on what I said earlier here. Are you following that? But this is the best answer. Okay, let's carry on. Let's carry on to that one. Now, this question here, it will be the first question where I'm going to introduce the concept of the constant. Okay, Tyra? This is the first question now. Right? You are going to understand it better because last time when I introduced on Friday, it was a bit of challenging to grasp what's happening. Okay, please do yourself a favor. You need to put your pen down because when I introduce it, then you need to see what I'm doing, because the concept of the constant is the key to help you to answer questions on the proportion theorem. That's the key, yes. Okay, please be aware, I'm going to repeat this. Understanding how to work with the constant is the key to answering problems on the proportion theorem. Okay, if you don't understand how to do it, you're going to have big problems with the questions. Okay, so obviously here we are told that W is a midpoint, okay, which means we might need to use the midpoint theorem, because the midpoint theorem and the proportion theorem, they are related. Okay, you can read the story here. This ratio here is very important. That ratio there. So first thing, I'm going to include it on my diagram, and I'm going to introduce the concept of the constant straight away. So we have got PQ over SQ is equal to 7 over 2. Now based on last Friday's lesson, if it's the same straight line, okay, like in this case, you have P, and then you have got Q, and then you have got SQ. So the 3 points are collinear. They belong to the same straight line. Okay? Therefore, we can use the same constant. So I'm going to call it K. You can give it any letter you want. So PQ over SQ is going to be equal to 7, 1. So what that means is this whole length PQ, I'm going to call it 7K. Okay, that whole length I'm going to call it 7K. Please be aware that 7 is not the length of PQ. Okay? Okay? It's part of the ratio. So the original length is 7K. Then SQ, okay, it's the smallest of the two, so SQ is going to be here, so that will be 2K. What this means is that PS is going to be equal to 5K. Okay? Now, let's answer the first question. So it says PT over TW. So we have got PT, so that's the length up to here, from there, and then TW, that's from here to there. Right? Now, since my PQ is 7K, and it means that, and SQ is 2K, obviously it means that PS is going to be 5K. Are you following that?
Yes, sir.
Right? So this is going to be 5K. Now, that will make things easier for me to get this ratio. Okay? So, for 2.1.1, I'm going to identify my triangle first. The triangle that I'm going to apply the proportion theorem. So that triangle is going to be triangle PQW. So this will be PQW. Why am I identifying that triangle? It's because inside it, there is a line which is ST, which is parallel to QW. So I can use the what? Proportion theorem. Right? So I'm going to write here PT over TW is going to be equal to, so it's PT over TW is going to be equal to PS over SQ. So that will be PS over SQ. Then you must give the reason here. Line parallel to one side of triangle. Yeah, please allow me to carry on the other side. Alright, then my PT, that's PT over TW, that's the one which I want. Okay, my PS is going to be 5K. And my SQ is going to be 2K. The good thing about using the constant is that whenever you divide lengths that have got the same constant, the constant disappears. Okay? And you would have been able to solve the problem. So this will be equal to 5 over 2. Okay, so that's the answer there. So the ratio of PT over TW is going to be equal to 5 over what? Over 2. Okay. Are you following? Any question? Any question? Yes.
So does that mean that PT is equal to 5 and TW is equal to 2?
No. You see, 5 over 2 is equivalent to 5 is to 2. So 5 is to 2, it's a what? It's a ratio. It's not the original length. The original lengths are going to be 5K and 2K. In this case, I'm sure you can see that the whole question here, we are not given the length of any side, which is a very common type of question for your proportion theorem. You won't be given any length, you can be given just a ratio. So you work with the ratio. Please, the ratio is not the length, okay? But the ratio is just like the values that originate from the actual lengths. Okay, so your original lengths here are going to be 5K and 2K. Okay, 5 is not the length of PT, 2 is not the length of TW. Okay. Okay, let me move on to the. Is there anybody who's got another question? Okay, if you don't have another question, then let's move on to the next one. So let me just copy this. So copy that. Okay, so let's move on to that one. Now we have to, so I still need my diagram, by the way. Okay, so I'm not done. I need to label the diagram again. So I've got my 2K here, and that's 5K. And now on the other side, that is along PR, I'm going to use a different, can you pay attention? Stop it and pay attention. On the other side, PR, I'm going to use a different constant, okay, because PQ and PR, okay, they are not equal in length. So I have to use different constants. So based on this answer here, PT over TW, it means if I take that ratio into account, my PT, I can call it 5Y. Okay, let me use a different color there. So this one I can call it 5Y, and TW I can call it what? 2Y. Okay? And from there now I can move, I need to find what is PT over TR. So this is your TR here. That whole length, that's TR. So I just need to identify a new triangle in order for me to get this ratio. Okay, so let me do it there. So we are doing 2.1.2 now. So the new triangle is going to be PSR. That's the new triangle. So if I'm to get this ratio, I'm going to use PSR. Okay? Now, okay, because it says PT over TR. Okay, I can also try to use triangle STR as well. Okay, I can use that too. Okay, but the problem now is that I don't know any length of SR, that is SB or VR. I don't know it. Okay, I only know TW, of which I don't know what is WR. Right? Yes?
So, can't you say WR is certain high because W is the midpoint?
Yeah, which means we in this case we have to apply the what? The midpoint theorem. Now if I apply the midpoint theorem, because this point here is the midpoint, actually it's not the midpoint, but it's the converse. Okay? Please be aware that it's the converse, because we are not told that PA is PS is bisected and PR is bisected. So we have to use the what? The converse. Okay. Now if we use the converse, okay, so here we'll say, okay, I've already in triangle PSR, okay, in that triangle, because point W it's a midpoint, I can write this and say P, it will be PW is equal to WR. Okay? And my reason for that, okay, well, you can't give the reason as a midpoint, but you can write that because W is the midpoint. You can write that, or you can say line through midpoint parallel to what? Second side of triangle. So I'm going to use the converse here. line through midpoint parallel to second side. Okay? Now, what this means is, if my PW is equal to 5y, obviously WR is going to be what? It's going to be, sorry, it's 7y. WR is going to be 7y.
If it's so for saying that PW is equal to WR, can't you say your reason is just given?
What?
Given.
No.
It says W is the midpoint of PR.
I would not encourage you to say it's given.
Yeah, so I
But what I suggest is either you write this, that W is a midpoint of PR is your reason, or you can use the converse. Okay. If you put given, it's not that, okay, what can I say? It's not perfect. That is the reason. Right? So here we can say, therefore, PW is equal to WR, and they are both equal to 7, 1. Okay? So this whole length here is going to be equal to 7, 1. Are you following? Right? Now, once I have that, I'm almost there now. Okay? I'm almost there. So the next thing now is to say, therefore, PT over TR, right? PT over TR. Now, here, you don't have to give any specific reason because you've got your diagram which is labeled and you have mentioned why PW is equal to WR. So I can write PT over TR. My PT is 5y. Okay? My PT is equal to 5y. My TR is going to be 2y plus 7y, which is what? 9y. So the answer there is going to be 5 over 9. Okay? I hope you are following. Okay. So PT over TR is going to be equal to 5 over 9. So, are you alright? Okay. Is there anybody who has got a question? Any question? Okay. Before I carry on here, I just want you to be aware that because of the fact that W is a midpoint, means point A is also a what? A midpoint. So PA is going to be 2.5 K, and SA is going to be 2.5 K. Because remember, PS is 5K, isn't it? So half of 5K is what? 2.5 K. Yes?
So please explain why you use the converse.
Okay. You see, you can only use the original midpoint theorem if you are told that a line bisects two sides of a triangle. So in this case, we are only told that W is a midpoint, which means AW only bisects what? PR, based on the information given. And it is also parallel to SR. So we are only given that, in this case here, AW is parallel to SR, and we are also told that W is a midpoint, which means PW is going to be equal to WR. Because we have a parallel side, which is parallel to one of the three sides of the triangle, and one side of the triangle is bisected, we use the converse. With the original midpoint theorem, if it was the original midpoint theorem, then we're supposed to be told that A is also a what? A midpoint. Okay? So in that case, it was supposed to be AP equal to AS, and then you have to be PW is equal to WR. Now, with the midpoint theorem, you won't be told that the line which divides the two sides of the triangle is parallel to the third side. So here we are told that AW is parallel to SR. If it was the midpoint theorem, The line which divides these two sides in proportion, or which bisects them, it won't be given as being parallel to the third side. Are you following that? So you have to be very careful, because for a question like this, you can be tempted to give your reason as the midpoint, which will be not true. Okay? All right, let's carry on. Now, one of the reasons why I added this 2.5K and the 2.5K is because we might need that information for the next question. Okay, so we are here now. PA over SQ. So I now know that this is 5y, that's 2y, and that is 7y. Obviously, this is 2k, and that one there is going to be 2.5k, and that is 2.5k. Okay? So if I want to get the length of PA over SQ, so it's now PA over SQ. Right? Now, I'm not going to rush to just write the answer. I need to show you how PA is going to be 2.5k. So I can use the proportion theorem even though we have got a triangle which requires the midpoint theorem. Please be aware that the proportion theorem and the midpoint theorem, they are what? Related. The midpoint theorem is a special case of the proportion theorem. So, because of that, I can say for 2.1.3, I can say in triangle PSR, okay, in triangle PSR, I want to determine the length of AP, okay? Because I can write straight away and say, okay, so that would be PA over AS. Okay, this is equal to PW over WR. Okay, so I can write this as PW over WR is going to be equal to, so my PW, okay, this one will be next. So let me just use the converse of the midpoint theorem and that. Okay, so I'll just say PA is equal to AS, and here I'll write a line through midpoint parallel to second side. Okay, now since PA is equal to AS, yes?
So how would you know when to use the proportion theorem? Because you are going to use the proportion theorem.
Okay, okay, what I'm trying to do in terms of finding the length of PA, you can use the proportion theorem, but it can be slightly longer. Okay, so I want to use the converse of the midpoint theorem to determine the length of PA in terms of K. But you can use the midpoint theorem, but it'll just be a little bit longer though. Yes. Okay, you can. So here we know that PS is equal to 5K. Am I right there? PS is equal to what? 5K. Since these two are equal, I can say, but PS is equal to PA plus AS. Right? So this is 5K. So here I can replace the AS by what? By PA. Do you agree with me then?
Yes.
Am I talking to myself now? So this is the same as 2PA. So PA is going to be 2.5. Okay. Okay. So I have proved that PA is really equal to what? 2.5K. Then I'm going to come here now. So this is going to be easy now. So PA over SQ is going to be 5 over 2 divided by, I'm using divided by because the ratio or the length of PA there, it has got a fraction, right? It's an improper fraction. So my SQ is 2K, so this will be 2K, right? So I can simplify this. You can simplify this as 5 over 2K times 1 over 2K. Okay, so these 2K's cancel out. So my final answer is going to be 5 over 4. Please be in the lesson.
Can I ask you to do the algorithm?
Huh?
Because I don't see how you do the algorithm.
Which one?
The way that you use
You see, if I use the proportion theorem to find the length of PA, okay, I'll get to a point where PW over WR will be equal to PA over AS. Still, I have to come to this. So if I take the root of the proportion theorem, it won't help me much, because I still have to come to this. The phone is confiscated. Can I have the phone? Okay. Right, is there anybody who has got a question? Okay, we don't have a question. I've got five minutes now. Let me do QV over VW. Now, if I want to do QV over VW, I have to identify a new triangle. Now, it's a little bit easier now, because I've got my lengths already in terms of K, so I'm going to use triangle AQW to determine the ratio of QV over VW. So it's easy now. Do you see that? Huh? Okay, let me duplicate this page so that you can follow what's happening. Alright, allow me just a second. Okay, so I'm done there.